Good morning, 6th grade. So if you're here, chances are that you've probably already done the work for Monday and you're just starting the work that is set to be done on Tuesday. So before we get started with anything else, the first thing that you should have already done is you should have already done the intro question. So for the intro question, what you're going to do is you're going to click into the Google Slides and you're going to watch two very quick videos, and then you're going to answer the question. The question is, how are these two videos related, and how are these tricks happening? So as you can see, nobody's commented. No, this isn't assigned to anybody because this is in our teacher planning page. But that will be a little bit different. What you guys are going to see is you're going to see a bunch of other students' answers. Before you do this activity, what I'd like you to do is watch those videos and then go answer that question. When you come back, you're going to look at those questions again, revise your answer, and comment on at least one other person's video. You might need to come back a little bit later to do that, because if you're the first one doing it, there's not going to be anyone else to comment on. So, if you've already done that, then you're ready for the Newton's first law activity. So, for this activity, what this is going to look like is you're going to open it up, and there's going to be, this video that I'm making right now is going to be on this as well, but there's going to be an online activity. So when that pops up, it's going to look like this. So the problem that you're going to do is you're going to get an index card, a glass jar, or a glass cup. I recommend one that has a fairly wide rim, so like a Solo cup or something like that if you have one around the house, and 3 objects that have different masses. So we discussed what mass was at the beginning of the year, so that's the amount of object in the amount of space. So the things that you could use for that, my low mass, usually when I'm in class I use a cotton ball, but I got just a ball of lint to use today. Second, medium mass, so somewhere in between the two, I'm using a small little clip. And high mass, I am using a charging block. So yours do not need to be the same, so long as you have one that is a really low mass, so something that feels like it weighs almost nothing, one that has a medium mass that has somewhere between feels like nothing and feels like something, and one that is a more hefty mass. You're going to put an object on top of the glass jar on top of an index card, and we're going to flick the card away and observe what happens. So before we get started, what I want you guys to do is to make a prediction. So you should do this in the form of an if-then statement. So if I use high, middle, and low mass items, then what do you think is going to happen? Do you think it's going to fall in the jar more? Do you think it's going to fall out of the jar more? Do you think it's going to fall in every single time no matter what? Just say what you think is going to happen. It does not matter if it's right or wrong. In here gives a little bit of background information on what we're going to be studying. Then the procedure. Okay, so at this point I'm going to show you what this should look like. So I've got my cup right here. I've got an index card right here. For each one of these, and you can use my information to kind of combine with yours for the class set of data. What you're going to do is you're going to put the card on top. Then you're going to take your item, put it on top, and then you are going to flick it so that it moves away from where it is right now. And then you're going to do this 5 times. So for the first one, I'll go here, and it did in fact fall into the cup. So that's 1, 2, 3, 4, 5. And each time it fell into the cup. Second one. I'm failing this time. 1, 2, 3, 4, 5. Now, 1, 2, 3, 4, 5. Now, I did that 5 times. You can add your information to my information. I want you to really look at what happened with each of them. Even though mine went in all 5 times, I want you to take a look at how they're moving. Are they going immediately in, or do they kind of waver a little bit? Because that's going to go into this a little bit as well. So if you need to go look back, please go back and do that. And really quickly, I'm going to switch this over here. You're going to record how many times it misses, how many times it falls in, and the percent of times that it falls into the cup. So to do that, you're going to add the 2, so there's going to be 5 trials. So you're going to do this number, whatever falls in this, divided by 5. Finally, you're going to have some questions. You're going to need to read that background information to follow some of them. You're going to need to explain how the inertia of an object falls into a cup, why it's necessary to flick instead of pull it slowly away, and then according to the class data, which mass fell in the most often. So you're going to have to look at your data and my data, and why, discussing mass and inertia. And then finally, how did the data that you and me collected show the same results as everyone's data, or what you expect would happen most of the time? If not, can you explain why? So, take your time, do this the best that you can, and I look forward to seeing all your results. Thank you.